Hello all. In this presentation, we will learn what UML activity diagram is, how to read their notations, and how they differ from the state diagrams. I will walk you through notation, examples, including e-commerce, railway, and flight booking. Also, we'll talk about the bank management system. And finally, we'll finish it with a knowledge test. Let's begin. UML stands for Unified Modeling Language. It's a standardized visual language used to model the software systems. UML contains many diagram types. Broadly, it's classified as behavior diagram and structural diagram. Behavioral diagrams shows how the system behaves during the runtime. Okay? That's why we have activity diagram there, state machine diagram, use case diagram, and we also have interaction diagram on it, where you have subtypes like communication diagram, interaction overview diagram, sequence diagram, and timing diagram. Particularly, this shows how the system behaves at the runtime. Coming to the structural diagram, it shows the static architecture, such as class diagram, composite structure diagram, component diagram, deployment diagram, package diagram, profile diagram, object diagram. So in short, I could say that the behavioral diagrams, they are for sequence diagrams for interactions over time. And the activity diagrams for showing the workflows. Whereas the structural diagrams shows the class diagrams for data models. So UML particularly helps the developers and also the non-technical stakeholders to speak the same design language. So that's what the main purpose of UML, that's Unified Modeling Language. A UML activity diagram represents the workflow or activities in a system or a process. It shows the step-by-step execution flow, including decisions, parallel flows, and the order of activities. Whereas the activity diagram, they provide the dynamic view of the system and are especially useful for modeling the business process and use case flows and also the logic inside the complex operations. Note that the activity diagrams model the process and not the object lifecycle. They answer what happens rather than the lifetime of an object. Hope it's clear, right? So why you need this activity diagram? Mainly for three main reasons. First, to visualize the workflows. That is, they make complex sequences easy to see at a glance. Second, they act as a basis for implementation, which means the developers use them to write test cases and implementation steps. Third, the activity diagrams improve the communication because they are simple enough for both technical and non-technical stakeholders to understand, making design reviews and requirement discussions more productive. So that's why we are using activity diagrams. Now let's walk through the core notation used in the activity diagrams. We have a start node. It's a solid black circle and it marks the process begins. An activity or action is drawn as a rounded rectangle. This is task or a step. A decision node is a diamond shape that branches flows towards on conditions. The control flow arrow shows the order of execution. The end node is usually a bullseye symbol. You can see here the final state, which marks the termination of the process. We also have swim lanes. It divides the responsibilities between actors or systems. They are vertical or horizontal lanes that shows who perform each activity. Yeah. Next, coming to the fork and join is called a synchronization bars. They are horizontal or vertical bars used to create and synchronize parallel flows. The fork splits into concurrent actions and the join merges them. Whereas the merge node and the decision node, their difference is the merge is a diamond that joins alternate flows, and the decision node distinguishes the conditions. They both look the same, but they are used differently. Yes, and coming to the final versus the flow final mode, activity final stops the entire activity. The flow final terminates a single control flow while others continue. Object nodes versus the data stores shows object being processed between the activities. Similarly, we have signal and interrupts. The activity diagrams can model signal and interruptible regions by long running workflows. So these are the basic notations used for the activity diagrams. Now we will apply the notations to concrete real-time examples. For each case study, I will reveal the activity diagram step by step and explain the discussions and the parallel task. Yes. So this is a simple thing which we have taken here. And here you can see that start node, this is the end node. And let us say that you are entering the username and password, trying to get the detail and submit it for validating the data. If it's yes, it's accepted. And if it's no, it's rejected. And it takes an error symbol and try to get the data again. So this is a general block diagram which we gave you. Now let me go for the first case study, an e-commerce application. So the case study here is an e-commerce company wants to streamline its online order process. A customer logs in or registers if new, browses products, add items to the cart, and proceeds to checkout. The system validates payment and stock availability. If successful, the order is confirmed and set for packaging and shipping. Otherwise, it's cancelled and the customer is notified. Now, for this case, draw an UML activity diagram to represent the sequence of activities in this online order processing system. This is our case study given to us. So here, note that the actors are the customer and the system, and we are going to use swim lanes to separate them, right? So let us begin with the start node. The user either logs in or chooses to register. Model this with a decision with two flows. Login successful and register then login. So after authentication, the customer browses the products and adds items to the cart. These are very simple actions. On each checkout, the system performs two validation. What are they? Payment verification and stock availability. You can represent these as either sequential checks or parallel checks using a fork. Many systems do them in parallel. Why? To speed up the processing. If both the checks succeed, the flow continues to confirm the order, which triggers packaging and the shipping. task. If either check fails, the flow goes to the cancel order and sends a notification to the customer. And that comes to the end of the final node. So what will happen when you make it them as sequential or parallel? So what are the advantages and disadvantages coming to that discussion here? If it's done parallel, we are going to use a fork at checkout and a join before the confirm or cancel, right? So for split and confirm join, we are going to use that. If sequential, then you have to focus on order of checks and the got conditions on the decision nodes. So this is the difference when we use it, when we make it parallel and the sequential. Yes. Coming to the second case study, it's a railway ticket booking system. It allows a passenger to log in or register if new, search for trains by date and destination, and select the preferred train. The system checks seat availability, after which the passenger provides his passenger details and payment. If payment and availability are confirmed, the ticket is booked and the e-ticket is generated. Otherwise, the booking is cancelled and the passenger is notified. For this, you have to draw a UML activity diagram to represent the sequence of activities in the railway ticket booking system. So starting from the login here, the passenger searches for the train by date and destination. After selecting a train, the system checks seat availability. If seats are available, the user fills passenger details and proceeds to payment. Correct? When the payment succeeds, okay, the booking is confirmed and an e-ticket is generated immediately. If the seat is not available, the flow can go to a waitlist processing or cancellation. If the payment fails, the flow returns to the payment retry or cancellation. We can also model a synchronous path for seat holding seats for a short time while payment completes. Right? Here, how could you add further models? You could also show the ticket object created on success with attributes such as PNR, seat number, all these things you can add. This can be drawn as an object node attached to the action that generates the ticket. Right? So with this, and finally it comes to your end node. Coming to the next case study. Here, an airline wants to improve its online flight ticket booking system. A passenger first logs in or registers if new, then searches for the flights based on the date and destination. So, after selecting a suitable flight, the system checks for the seat availability. The passenger enters details and proceeds with the payment. If the payment and the seat availability are confirmed, the ticket is booked and the e-ticket is generated. Otherwise, the booking is cancelled, the passenger is notified. So for this, you should draw the UML activity diagram. So begin at the login or registration as usual. The passenger searches for and selects a flight. Correct? So after the selection of the system, the system offers the seats selection and add-ons. We model these as optional parallel actions so that the user can choose any combination, whatever they want. After the passenger details and the add-ons, the payment is attempted. So if the payment and the availability are confirmed, the system creates an e-ticket and issues the itinerary. If any steps fails, for example, the payment fails, the flow sends an error notification and the optionally offers the retry or alternate payment routes. So this is one such example for this UML activity diagram. Next, the other case study is with the bank management system to handle the customer transaction efficiently. A customer first logs in or registers if new, then selects a service such as depositing money, withdrawing cash, and checking balance and transferring funds. The system verifies account details and ensures sufficient balance for withdrawals and transfers. If the transaction is successful, the system updates on the account records and generates a confirmation receipt. Otherwise, the transaction is declined and the customer is notified. So for this, you have to draw the your activity diagram. So as usual, let's start with the start node here. The customer chooses an operation. Then for withdrawals or transfer of the system, first verifies the identity. First, it should verify the identity, right? After registration, it goes for checking the identity and then checks if there is any sufficient balance in it or not. If you have balance or only then you can go for withdrawal, right? So balance or not. If the verification on the balance checks pauses, the transaction executes. Account records are updated and the receipt is being generated. If any check fails, the transaction is cancelled and the user is notified. So for robust system, we model the transaction atomicity by choosing a commit node or an activity final the represent the rollback on failure. Otherwise, it leads to failure. If multiple concurrent transactions might affect the same account, mention the modeling logs or serialized access as nodes. Though they are not typically drawn in the UML activity diagrams here, they are important considerations to be noted here. Yes. So this is an example for the bank management systems. And coming to the difference between the uh, state diagram and the activity diagram. Yes. So coming to the purpose, the activity diagram, we'll see about the activity diagram first. The activity diagram models workflows and concurrency, whereas the state diagram, the models the states of an object goes through during its lifetime. Coming to the focus, activities emphasize the sequence and flow of the control, whereas the state diagrams emphasize states and the events that cause transition. Use cases, use activity diagrams for business process, okay, for such applications and wherever you need user scenarios and algorithmic flows. Use state diagrams for objects like orders, user scenario, or devices where states and transitions are centralized. Activity diagram uses action boxes, decision, diamonds, the forks, join, state, which we have seen till now. Okay. Whereas coming to the state diagram are focused on the single entity states. So I can just say in one line that activity diagram answers what steps are performed and the state diagrams answers what state is the object in. Yes, let's see one example for a state diagram. Yes, here an order can be modeled as an activity state diagram showing the process to place the order, or a state diagram for the order would show states like new, paid, shipped, delivered, and cancelled, like that. So here a simple state diagram for an online railway reservation system. The life cycle begins in the ideal state. When a user searches and selects a train, the booking object moves to selected. After passenger details are entered, it moves to the pending payment. If the payment succeeds, the object transitions to the booked and a ticket is generated. Ticket generated action will be running. Moving to issued state. If payment fails, the object moves to cancelled or to the payment retrace state depending on the retrace. If seats are unavailable, you might transition to waitlist and later to booked when a seat becomes available. So now coming to the quick questions for just for your understanding. I will read each question and pause briefly to allow you to think for the answer. Question 1. What does a UML activity diagram mainly represent? In an activity diagram, the black filled circle represents. Which one is not a component of an activity diagram? Parallel activities in an activity diagram are shown using. In an activity diagram, the shape used to represent an action or task is. An UML activity diagram or most similar to which of the following? Yeah, hope your answers are correct. Thank you.